A digital twin is a digital representation of a physical asset, both in terms of what it looks like, but actually what it's doing in near real time. And also, a lot of digital twin, or the perception of digital twins, is that it's something that's utilized in the operations phase. It's something that's utilized to help you to maintain your asset. What we're starting to see now, and although it's not something that I'm going to talk about in detail, but what we're starting to see now is the digital twin being utilized much earlier on in the construction life cycle. So we're seeing digital twins being created at the construction stage. We're putting sensors into structural elements that allow us to judge when we can strike them and help us to plan and execute our projects. And that same sort of mindset and those same technologies are now then being able to be fed into the operational stage, which is what we consider, or what we've been talking about, as a traditional digital twin. So digital twins actually haven't been around for that long. It was funny that Jacques mentioned about the Apollo. So the term digital twin was actually coined by someone who worked for NASA in 2010. The concept itself has been around since about 1991. I think it was first mentioned as a concept in a book called Mirror World. So it hasn't been that long since the sort of term and the terminology of digital twin has been around. But what we're seeing now is the convergence of various different technologies coming together that allow us to make practical representations and practical applications of digital twins. So there's things like the cloud, IoT, 5G now I think is going to come and accelerate the use of this. And then there's also the skills side of it as well, right? So up until this point, I think that there hasn't been the skill set within the industry to be able to utilize these technologies, to bring these technologies together. In terms of what the digital twin comprises of, there's the visualization element, which is usually comprises of a BIM model and a 3D geometry in various different guises. There's also the 2D information and the drawings, which can be visualized. There's the real-world building systems, things like your BMS systems, your CAFM systems, your SCADA systems, and all of those integrated into. And some of the use cases that we talked about are things like what we're seeing is utilizing the digital twins to get a measure of what your building is doing, how it's behaving, to then try and optimize that for things like achieving net zero carbon and for reducing your operational costs, but also to allow you to then repurpose your building when it starts reaching the end of its life. So if you've got a real digital twin which is capturing data on how the building has been used, how it's behaving, and the assumptions, or validating the assumptions that were made during design. When it comes to renewing that asset or doing something different with that asset when it comes towards the end of its useful life, having a digital twin is going to have a massive benefit there. On the actual project that I'm talking about at the moment, you saw a screenshot of it on the very first page. I can't talk about it in name, but if you've been to Riyadh, you most certainly would have driven past it. It's a collection of buildings that essentially is eventually going to be the equivalent of DIFC or Canary Wharf in London for Riyadh. And it was a project that was left half finished just before the previous financial crisis. And the client basically wanted to, or realized that they didn't have accurate information about what was there. There was 48 buildings, and on average, there was 77% completion on each of the buildings. And some of the buildings were topped out, but the glazing was part completed. Some of the buildings hadn't even completed the internal structure. And so the buildings were in various different stages of completion, and so there was no easy way of capturing what was there and then knowing how long or how much it would take to complete it. The other things were that seven of the buildings were really close to being finished and ready to go into operations, and so they wanted to obviously monetize those. The whole point of approaching us was because there was a lot of incomplete or missing data. The client came up with a vision that they wanted to digitize all of this information and essentially be ahead of the curve, and then turn it into a world-class operation. So many of the buildings within this district were going to be operated by the client themselves, and one of the biggest issues that they've had from previous, and I think a lot of operators have the same issue, is that the accuracy of the data inhibits the efficient operation of them. We proposed and actually implemented a workflow and a journey to get to a digital twin. The first thing that we did was we actually purchased our own scanning equipment because we realized the scale of this project. So we ended up scanning close to 3.3 million square meters of floor area. So a vast amount of laser scanning was undertaken. And the most efficient way of doing that was to do that ourselves with laser scans. In the initial stage, we took all of the buildings, so there was 48 buildings. We took them up to LOD 100 and then upgraded those to LOD 200 and 300. And then we worked with the existing contractors and with the client's existing operating staff to start collecting the information and matching it up to what we've got. Then 7 of those buildings we actually took to LOD 500. So this involved integrating all of the asset information, the information around the individual elements of that building. And we brought it all together into a common data environment, which is slightly different from the common data environments that we're all used to in BIM. So this common data environment needed to be utilized for the operation phase. So it has subtle differences, nuances that we needed to do. And also what we realized is that we could utilize the information that we'd captured using during the laser scanning process to actually help to sell the lease the space. So we also integrated a virtual tour and platform. And actually it turned out to be a really good job that we did that, because we ended up going into the COVID situation, which meant that the client was able to basically take prospective leaseors around the buildings in a virtual environment. So some of the deliverables that came out of this, so we started with a vision document to ensure that everybody was aligned in terms of what was required and where we wanted to go. Through the laser scanning to BIM process, we created BIM models that were appropriate to the level of information that was required at the time. Our common data environment brought together the various different elements of data, so the 3D information from the BIM models, the sensor information that was coming from the alarms in the BMS system, the space data which was derived from the parameters inside the BIM model, and the CAFM information. We integrated all of the CAFM systems directly to the BIM via this the CDE, and we also at the same time integrated it with the various different BMS systems. And this was one of the challenges which I'll talk to you about in a second. So in terms of the biggest challenges that we had, the biggest one was actually managing the cost, because we had multiple different platforms which had different levels of appropriateness and integration access to it. And so for us, going into this, I guess we were a little bit naive, and it was the first time we'd certainly done it, and probably the first time many of the people, even across the table from the client side, had done this. So managing the cost of the integration was a big issue. The standardization of project information before we got there was a massive issue, and so that was a huge lessons learned. And this is something that we've now taken on, and we're advising clients on now, is the importance of making sure that if you've got a portfolio of projects, you're standardizing the way that you receive this information. The short time frame in terms of the integration. So the issue that we had was that we were doing an integration between BIM and the BMS and the CAFM systems at the same time as they were doing their implementation. So that meant that we were trying to do two things, and one of them was very, very new at the same time. And there was also the poor data that was available. The input data was either non-existent or inaccurate. We actually found that about 550 assets were either not in an asset register, or there was incorrect in terms of the data that was there. So some of the benefits that were realized: there's a live digital twin where you can view the BMS sensor information in a 3D environment. You can see all of the different assets that are associated with that particular alarm. So that saves people having to go there and do an investigation actually on site. You can do that investigation digitally. You can perhaps even order the part before getting there, and so it saves time in actually doing it. The fact that we've got accurate BIM models of the shell and core spaces now helps with the follow-on trades and the fit out. We were able to reduce the cost to the client. So in terms of the whole process of digitization, we were shown to be a lot cheaper than if they'd gone to a traditional sort of design consultant route. The live integrations across all of the real estate departments. So this is not only just helping in the operations, as I've alluded to, it's helping with the leasing, it's helping with the transactions, and it's going to be helping with the fit out of the leasing spaces. And one of the other big ones is the data optimization for future use cases. So at the time when we completed this, the whole ESG sustainability agenda was important, but it wasn't as prevalent as it is today. Now the fact that the client has this rich BIM model that they can use as a basis for going forward means that they'll be able to effectively implement any of their sustainability goals.